Okay, so here we go. We're in section 1.1, part 2. So the plan today is to finish 1.1 and 1.2. That's what our schedule says, right? Because 1.1 and 1.2 are both supposed to be due on Monday. So we got to get it moving. All right, so here we go. So find a positive angle less than 2 pi that is coterminal with the given angle. That's fancy talk. What does that coterminal thing mean? What does co always mean in front of a word? With means with. My English teacher, senior year, made us memorize all these prefixes and suffixes. I hated it at the time. She said it would help us. She's right. It actually helps you to love it. Co means with. Whenever co's in front of a word, it means with. Terminal means ending. To terminate is to end. So coterminal, ending with it. So ending in the same spot, in other words. That word means ending in the same spot. So for example, if you have an angle, say that's like, 30 degrees, right? Let me just make up a 30-degree angle. There's a 30-degree angle. Or you could take that angle and you could say go all the way around 360 and 30 more, 390, and it's the same angle, coterminal. You get it? Those are really the same angle, right? It'd be like me saying, all right, I'm going to spin all the way around and then quarter. So I could face the back, or here, I could face the front and turn a quarter turn to the right, and I'm at the door, right? Or I could face the front and say, no, I'm going to turn all the way around and a quarter turn. Same thing. In the end, I end facing the same direction, right? Co-terminal, ending with the same spot. So that's what they're saying. They're saying find another angle that ends in the same spot. That's what they're really saying. Well, how do you do that? 48 pi over 5? That's kind of crazy. Find another angle that ends in the same spot. You could do it. What would I do if they gave me like 1,020 or something? Some gigantic angle, and they said, find an angle that ends in the same spot. What would I do? What would I do? Subtract a bunch of 360s, right? Because whenever it's more than 360, just take out those extra loops, right? Take out those extra 360s. Well, that's exactly what we're going to do here. This is a whopping big angle. This is like several loops. In radians, though, remember it's in the other system, the radian system. So I'm not going to subtract 360, but I'm going to subtract full loops in the radian system. Because 360 is the degree system. That's in radians. I got to work in radians. So how do you subtract a full loop in the radian system? A full loop is 2 pi. Do you remember that? Do you remember that from Monday? Remember, all the way around a circle is 360 degrees or 2 pi radians, because halfway around is pi, isn't it? Remember, pi's 180. That's the bridge between the two worlds. Pi's halfway around. Pi's 180. And so 2 pi is 360, right? So instead of subtracting 360, subtract a bunch of 2 pi's. That's exactly what we'll do. So let's come on in here. And I'm going to say, okay, subtract 2 pi a bunch of times until that angle comes down to something more normal. That's what they're saying. Make it less than 2 pi. Bring it down to within one full loop, not more than a loop. Okay, so now, let's get down, now that we know what we're supposed to do, how do you subtract 2 pi? Common denominator. This is over 1, right? Whole numbers are really over 1, aren't they? And then, now what? Oh, yeah, you already said it. Common denominator. Now I make it a common denominator. Top and bottom by 5. So that's going to be, what? 48 pi over 5 minus 10 pi over 5. That's a fancy 2 pi, isn't it? 10 pi over 5, that's 2 pi. So when I subtract 10 pi over 5, what do I get? 38 pi over 5. Now what do I do? Subtract another 10 pi over 5. You just got to keep subtracting 10 pi over 5 because that is subtracting 2 pi. Everybody with me? So do it again. Subtract another 10 pi over 5. And you get 28 pi over 5. Subtract another 10 pi over 5. Get 18 pi over 5. Subtract another. Here, let me bring it over here. It's a lot of these. I really could have just subtracted 40 pi over 5, huh? That would have been quicker. But whatever. We're getting there. 18 pi over 5. Subtract one more time. And I get 8 pi over 5. That's our answer. See, that's less than 2 pi. How do you know that's less than 2 pi? Because that's what they said. Less than 2 pi, right? 5 goes into 8. Less than 2 times, right? 1 and something. 1 and some change, right? So that's my answer. That's when. How do you know that's coterminal? How do you know that ends in the same spot? Because I just took out full circles, right? Whenever you go a full circle, you're still facing the same point when you're done. So there it is. Does that make sense? How to do that? So if you're in degrees, you just subtract 3/60. If you're in radians, you just subtract 2 pi's with a common denominator. Okay, so they're giving me the same thing, negative 31 pi over 6. Same thing, they want me to, make it more regular. Make it a positive. They say make it a positive angle. Right now it's negative, less than 2 pi. Now let's make it within one full loop, positive. That's what they're saying. Make it normal. So what am I going to do? Add some 2 pi's, right? Because that one's negative. You got to make it positive. So this time you're going to add a bunch of 2 pi's. So let's do it. So I'm going to add 2 pi, but get a common denominator. Go ahead, let me let you do that real quick. Get a common denominator, right? That's over 1. Any whole number's over 1, or whole expression, 2 pi's over 1, common denominator, and then just add it until the thing becomes positive. So top and bottom by 6. So minus 31 pi over 6 plus 12 pi over 6. What's that? Calculator. Is it 19? Minus 19. And then you add another 12 pi over 6, and it's minus 7 pi. You got to do it again because you got to make it positive. Add another one, and you get 5 pi over 6 done. We good? To just add or subtract 2 pi's. For radians, 360 for degrees. Make them normal. They're just having you change weird old angles to normal. That's all we're doing. Coterminal. Ends in the same spot. All right, I'll move. Okay, so we're talking about arc length here. Find the length of the arc on a circle of radius r intercepted by central angle theta. So I gave you the formula last time. Remember that? It's S equals r theta. That's for arc length. Meaning if you have a circle, and you have some angle theta, that's how long the arc is. The arc, we call it S. I don't know why we use S. I have no idea. Why don't we just use a big A? I don't know. Whatever. Arc length for a radius r, angle theta. So if you have a circle, an opening angle theta, radius r, how big of an arc, how long is that arc length? Well, it's r times theta. Remember that formula? You can write that on. You get a 3x5 card for every exam. Our first exam is, it's week after next, isn't it? Week after next, 2 weeks from today is our first exam. You'll have a 3x5 card you can use for that. And you want to write that formula on there for sure, but there's something I'm leaving out. Something important.
It has to be in radians?
Very good. Theta must, this is really important, be in radians. That formula simply will not work nor be the truth if theta is in degrees. Notice what they're doing. They're trying to trick us. They gave me theta in degrees. So notice, let me do the problem wrong. I think that'll be helpful. Don't write this down. If you just go, okay, I got it. S equals r theta. R's 11. Theta's 305. So it's 11 times 305. Hit the buttons on your calculator. There it is. It'll be wrong. It'll be wrong. Why is it wrong? What do I need to do? Got to change that to radians. So how do I take the 305, which is degrees, and change it to radians? Remember what we learned? What's the bridge between the two worlds? 180 and pi. They're the same thing, right? 180 degrees is pi radians. They're both halfway around the circle, aren't they? They're equal. Now, how do you know which one goes on the top and the bottom? Remember we talked about that?
The one you're trying to...
You want to cross cancel. Yeah, you want it to cross cancel. That was the big, bless you, lesson I learned in Chemistry 3A. I don't know if you've taken that or will take that. Was that unit conversion. I was like, oh, right after the exam, I got it. So the degrees go on the bottom because I want degrees to cross cancel. Units cross cancel like everything else does. That was news to me at that point in time. So I put the pi on the top. So there we go. And then this is over 1, so what you get is 305 pi over 180. So far, so good. And then I got to reduce that. So just divide by 5 in your calculator, top, bottom. Actually, maybe they just want a decimal. I think they just want a decimal in the end. So who cares? Who cares? I'm not going to reduce the fraction. They said decimal in the end, I believe. So I'm just going to plug it in. So r times theta, what was r again? 11. And then theta, I'm just going to leave it, 305 pi over 180, and just hit the buttons on your calculator. I believe, don't they just want decimal?
Integers or fractions?
Yeah, but then they just want decimals, so just hit the buttons. You know how to do that, right? 11, just multiply the top, divide the bottom, right? And your calculator is 11 times 305 times pi. Got to use the pi button. So you have that somewhere in your calculator. If you have trouble finding it, grab me after class. Be glad to help with that. Every calculator is a little different. Find where yours is. If you have trouble, grab me after class. So I'm getting 58. That's a 5 there. 58.555. They want me to round to 2 places. Remember how rounding works? You circle the place you're going to stop in, second place, they told me. Look 1 to the right. If the 1 to the right of that place is 5 or more, you go up, don't you? So it's going to be 58.56. 58.56 what? Feet. Right, because we're in feet here. The radius is in feet. That's actually how, if you had a radius circle of 11 feet, if the radius of a circle was 11 feet and the angle was 305 degrees, the arc length would be 58.56 feet long. That's how long that curved arc section would be, is what we're saying. They're being real picky. So this is the second answer they want. Yeah, first I do have to reduce that fraction. Yeah, let's come over here, then let's reduce this thing. What's this, divide by 5? Top and bottom. What's 305 divided by 5? 61, so it's 11 times 61 pi over, what's that, 36? Yeah. And then, okay, so I'm going to give a fraction answer also. So what do you do when a whole number interacts with a fraction? 11 times that fraction, put it over 1, right? It's in the top. So 11 just multiplies to 61. Use your calculator. It's 671 pi over 36. So there's the fraction answer. Reduced, that's as reduced as it'll get. Right, I divided 5 top and bottom. It doesn't reduce any further. And there's the decimal. Yeah, thanks. They want them both.
Those would both be in feet, right?
Yeah, those are both feet. Even though that one looks kind of weird, it is feet. Yeah, you don't have to type in feet, right? But it is in feet. That's true. There it is. Good. Good. You can be doing your homework if you want. Like I said, you can have your phone, your whatever laptop. You can be doing it. Yours will be similar, just different numbers. Now they want how much area. So you know what I mean? So we're saying, okay, you got a circle. Oops, that's a terrible circle. Whatever. And you got an arc, and they want to know how much space is in. What's the area? Like if it's, a piece of pie or something. How much pie is there? Not just the edge, not just the arc edge, but the total area. Well, got to give you another formula for that. Area. So, area equals 1/2 r squared theta, theta in radians again. Is that right? Let me make sure. I always forget that one. Is that what it is? Is that what the formula says? I kind of half remember it, and I don't want to tell you something false. Let me see. Yeah, right. Good. I got kind of lucky. There we go. It's right. 1/2 r squared theta. So you put that on your 3x5 card for the exam. There it is. Let's use it. Again, theta's got to be in radians, though, for both of these formulas. Okay. So let's do it. So the area is 1/2 r squared. R is 8. 8 squared theta. Now theta's 120, but we've got to change it, don't we?
Yeah, you
Convert it to radians. So you know the deal. Pi over 180 degrees, so the degrees cancel. So you get 120 pi over 180 radians now. And then can you reduce that?
2/3.
Yeah, exactly. Good job. Divide top and bottom by 60, would be the quickest way. Yeah, good. Divide by 60, divide by 60. That would be 2 pi over 3. So there's my theta. Everybody tracking? This is the r, this is the theta, right? 1/2 r squared theta. So now let's work that out. 1/2 r squared theta. And we'll have, let me see, 8 squared 64 times 2 pi over 3. Good so far? Okay, so what do we do here? Put the 64 over 1. Remember, whole numbers, when they're interacting with the fraction over 1, you can cross cancel far away like that. Doesn't matter, anywhere. Because the order doesn't matter. They all just multiply together. You can move them around. So just cancel those two. What are we left with? 64 pi over 3. That's all that's left, huh? 2's canceled. That's the exact answer in terms of pi. If they want a decimal afterwards, just hit the buttons on your calculator. Good on that. What's the units on that? Well, they're telling you. Square inches. That's area, so it's square units. That's how much, area like carpetings and square feet, it's always actual squares. That's what that is. That's how many squares, square inches is tiny. Square inches fill up that piece of pie. Good there?
I have a question.
Yeah.
So I noticed like on the calculator, like it'll put the pi next to the fraction. Does it matter where the pi symbol is at in the fraction?
Oh, good question. It does not. You can put the pi in the front like that. That's totally the same answer.
Okay.
Yeah, or you could actually put the pi in the front. Because pi is just a number, and remember, the order that we multiply numbers never matters, huh? 2 times 3, 3 times 2, 6, either way you do it.
So it's just another symbol of a variable.
It is. It represents a number, yeah. So you could write it that way. Why is it okay to put it in the front? Here's a good question that students often ask me. Is it okay top, front? It is, because anything alone is really over 1. It's the same as in the top, isn't it? So to be in the front is to be in the top. They're the same thing. And Math Excel knows that. It'll take it any of those ways. And make sure you know that for our test 2 weeks from today. Multiple choice, if you have this and option C is that, grab it. That's the same thing. So that you know that as well. Good question. All right. So what they're saying is, hey, you got an angle right here. What's that angle? Let's just answer the first question. I'll show you what they mean by the second. So they're saying, hey, what's that angle?
30 degrees.
Well, it looks like it's halfway, right? This one's right smack in the middle. Straight up, this is 0. Straight up is how much?
90.
90. Remember, because this is 180 halfway and 360 is all the way around. So if 90 is straight, right, and 180 is halfway, 90 straight up, what's half of 90?
45.
That must be 45 degrees, right? Now, I think they want radians. So we could give them we can convert that to radians for them. Let's start with degrees. So that's 45 degrees. Let me get the two answers they want in degrees, then we'll just convert them to radians. So it's pi over 4 if you happen to already. Is that true? Yeah, it is pi over 4. Anyway, we'll convert in a minute. So that's pi over 4 in radians if you already know radians. But I'll show you how to get that in a minute. Now, what's the other answer they want? They want negative. If you look over here, they're saying they want a negative answer and a positive answer. So how do we say that same ending spot as a negative angle? Well, you go down instead of up, huh? So you always start at 0. They decided to make 0 straight to the right. They made that up. They could have made 0 straight up like a clock. But they said 0 is going to be straight to the right. So starting from there, if you go up 45 degrees, you hit that dot. If you go down a whole bunch of degrees, you can hit that spot too. How many degrees?
315.
Yeah, good. Because, so if you go down, now let's call negative angles. If you go down, this would be negative 180, right? So negative 180 to there. This would be negative 270 to here. And then 45 more. 270. 270 plus 45. Do you see how I'm coming up with that? Negative 270 and negative 45 more is negative 315. Is that too quick? Do you see that? I'm saying this same dot arrived at by negative turning, going down first, you go negative 180, negative 270, right? Every one of these marks is 90. 90, 180, 270, negative now. Negative, negative, negative 270, and 45 more. Right? So if you turn all the way to here, that's negative 270. It's also positive 90. See how the same locations can be found by a positive turn or a negative turn, right? So it's negative 270 and then 45 more, because again, that's half of 90, isn't it? So 270 and 45, 315, negative. So our two answers so far, we have to change them to radians, are 45 degrees positive and negative 315. Those are the same. They both get you to this dot, don't they? That positive and that negative degrees, and they want radians. And now, how do we convert to radians? You know the deal. Pi over 180 degrees. Pi over 180 degrees. Right? Pi over 180. So put this, remember whole numbers go over 1. 45 is over 1. Use your calculator. 45 cross cancels. Well, here, I'll maybe write it this way. 45 pi over 180. Let me just do it this way. You can cross cancel or just put it together first. If you divide that in your calculator, 45 goes into 180 4 times. That's pi over 4, as I was saying earlier. And then the bottom one is going to be negative 315 pi over 180, because again, whole numbers are over 1, right? 315 is over 1, it goes in the top. And then reduce that thing, divide top and bottom by 5. Or if you have some of those, I showed calculators last time, didn't I?
Yep.
Yeah, if you have like a calculator that does the fractions, it'll do it for you automatically. Casio Natural Display or one of the nice TIs. I don't know what it is. Was it 63? I think 63 pi over 36. Is that right? Oh, and then it reduces again. No. Yes, it does. Divides by 3 again, huh? Am I doing that right? Is that those the right numbers? Oh, 9. 9 would be quicker. Yeah, 3 would work, but 9 would be even quicker. I'd have to do 3 again. Yeah, divide by 9. Thanks. So that'd be 7 pi over 4. There it is. So the two answers are pi over 4 and negative 7 pi over 4. Is that good? If you have some of those nicer calculators, you can just type in 315 over 180. Don't worry about the pi. You know the pi's there. Just type in 315 over 180 and hit equals, and it'll reduce it automatically to 7/4. Saves a little bit of time. You know what I mean by that? Using the fraction buttons on the calculator, you can save a little work on that. Now, if you learn the Radian system, you don't have to. You can just do this every time. But if you become more and more comfortable with Radian system, you can just snap out that answer. Basically, here it is. Let me just show you how you could have got that answer right away. You know you're right in the middle here. Sorry, I'm not a very good drawer. But right, it's kind of a squished circle. But anyway, right there in the middle. So what is that? Well, you know this is pi, right? Halfway around is pi. So this must be pi over 2, because it's halfway to pi. So this must be half of that, pi over 4. It's got to be. Now, I don't know if that grabs you or not, but I'll just say it if it's helpful to some of you. And then negative, starting at 0 again. Negative, this would be negative pi, going negative now. Negative, well, basically, every half a turn, yeah, I don't know how to make this easy for you. I know how to make it easy. Every quarter is a quarter of a pi, isn't it? So look at this. 1, 2, 3, 4, 5, 6, 7 pi's over 4. That'd be the other way. You could just, boom, there's my 2 answers. Because anytime you go a quarter of a way, like, well, anytime you go halfway in a quadrant, that's a pi over 4, right? Because halfway is pi, half of that's pi over 2, half of that's pi over 4. So anytime you go half, you just count them off. 1 pi over, I'm going negative now. Negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4, negative 6 pi over 4, and negative 7 pi over 4. Anyway, either way. Well, I guess maybe it's working. All right. We will see. All right, so here we go. So find the positive radian measure of the angle that the second hand of a clock moves through in the given time. So when the second hand, so the clock in the back, see the little red hand that's moving around, that's the second hand, right? They're saying when that red hand has gone through 7, it's the second hand, not the minute hand, right? You track with me, it says the second hand. So that's why I'm doing the red one, not one of those 2 black ones. Right? We have the hour hand, the short black one, the minute hand, the long black one, and the second hand, that red one, which is moving around. They're saying after 7 minutes and 30 seconds, what amount of angle has that red second hand gone through? How much angle has it turned through? So every minute, each 1 minute, the thing goes all the way around 2 pi. They probably want radians. Yeah, answer in pi. 2 pi all the way around, right? Wherever it starts, doesn't matter. It goes all the way around every minute. So it's going to go all the way around 7 times. So far, so good. That's for the 7 minutes. Is that making sense? Every minute that hand goes all the way around, doesn't it? That's 2 pi angle. And 30 seconds, how far does it go in 30 seconds? Plus halfway around, right? 30 seconds, it goes halfway around. What's halfway around in radians? Pi, right? 2 pi's all the way. Pi's halfway. Remember pi's 180, it's halfway. So it's 7 2 pi's and 1 more pi. So that's 14 pi plus 1 more pi. That's 15 pi. That's the angle through which it turns. You could have done that in degrees. It would have been 7 360s and then a 180, whatever that added up to be. They wanted it in radians. Make sense? Okay, so really you can just ignore everything they said. Doesn't matter, minute hand, second hand, hour hand, person standing in the middle of the street, whatever. 2/3 of a complete revolution. That's all I need to hear. Somebody was facing some direction and they turned 2/3 of all the way around. That's what they're saying. So it doesn't matter what hand it is. If you turn 2/3 of all the way around, you did 2/3 of 360. Complete revolution, that's 360, right? And of in math always means times, multiply. 2/3 of 360, huh? Doesn't matter what hand. That's just useless information. That could be anybody turning around or anything turning around. 2/3 of times a complete revolution. 2/3 of 360, use your calculator, it's 240. And then they wanted in radians also 2/3 of 2 pi, 2/3 of a complete revolution. That'll be 4 pi over 3 because this is over 1. Done. Good on that. 2/3 of a complete revolution. All right, I'm going to move on. So they're wanting me to find the length of an arc. Like how long is this section right here? That's what they're saying. Find the length of each of the 4 arcs. Right? There's 4 of these. 1, 2, 3, 4. So they want one of them. They're all the same, yeah. So how long is that arc? Well, arc length, we use the arc length formula. S equals r theta. Just use the arc length formula. What's the radius? They told me 28 inches. What's the theta? For this arc here, what angle opens up for that arc? It's 90 degrees. Everybody see that? So 90 degrees. But it has to be in radians. Remember, when you use this or the area formula, this must be radians. It simply won't work with degrees. The formula is designed for radians. So I can't put, it is 90 degrees, right? That is a 90-degree angle there. But I got to change it to radians. What is 90 degrees in terms of radians? Pi over 2, right? Because remember, pi's halfway. Pi's 180. So pi over 2, 180 over 2, that's the same as 90, isn't it? Is it okay if I just do it that way instead of a formal changing over? It's just good if you just really know clear. Pi's 180. Pi's 180. So pi over 2, that's 90, isn't it? Okay. So then let's simplify that. What do we do? How do we do a whole number with a fraction? Over 1. 2 goes into 28. 14 times 14 pi, done. 14 pi radians is how long each of those arcs is. All right, I'm going to move on quickly. All right. So, number 26. We're talking about the distance between 2 cities. Now, we think of the distance between 2 points on the surface of the earth as straight, but really it's curved. The earth is round. Galileo was right? And that you know quite well. So the earth is round, so really it's an arc, isn't it? Distance between cities is really a curved arc. So the arc length formula really is technically what is used. Now in reality, when cities are close, then you can just kind of estimate them as straight. But when they're far apart, like different continents, you need to realize that's curved. So S equals R theta. Can you see we have a little triangle here going down to the C. What's the C? It's the center of the earth, right? See how they're going to the middle of the earth there? And they're saying the radius of the earth is 4,000. Did you know that? So all the way across the earth is 8,000 miles. The radius from the middle to the edge of the earth is 4,000 miles. So 4,000 miles, S equals R theta. So we want to find this. This is S, the arc length from there to there, which is how far apart those cities are.
It's 60,000.
Which is 6,000. Yeah. So the S is 6,000. The R is 4,000. And they want theta. So the S is 6,000. The distance between the cities, which is an arc length. The radius of the earth is 4,000. Solve for theta. They want theta. How do I solve that equation for theta? Divide by 4,000. So isn't that 1.5? 1.5. 1.5 what? I had an old physics teacher. If you ever gave math we like the numbers. Physics, they care about what the thing really is. And he would always, Mr. Grimes, he would always say, if you ever gave an answer like 1.5 and you didn't tell the units, he would always go, 1.5 what, Heron? 1.5 dogs? Is that dogs? Is that 1.5 dogs in the kennel? That's what he would always say. So what is that, 1.5?
Miles.
Manner, it's an angle. In fact, it even says it right here. It's radians. Now, how do I know it's radians, not degrees?
Because the formula solves for radians.
Because the formula is automatically in radians. Remember when you use S equals R theta, it is in radians. So that's why I know that's a radian angle. That's radians. Now, they want the radian answer first. There's their first answer. That's part A. But then in part B, they also want degrees. So you take the 1.5 radians. Oh, yeah, this is the first time we've gone this way. Let's convert. Let's convert it to degrees. How do we convert 1.5 radians to degrees? So this is over 1. Any whole numbers over 1. You know the bridge, the 180 pi. That's the bridge between the two worlds, 180 and pi. So which way do I do it? Yeah, because you want the pi radians down here and the 180 because you want radians to go away, huh? Yeah, making sense? Units cross-cancel. Mr. McCallum taught me that in Chemistry 3A just the other day, or 30 years ago, something like that. All right, so there we go. 1.5 times 180 over pi. Just hit the button. If they want a decimal, just hit the buttons on your calculator, whatever that is. Use the pi button. 1.5 times 180 divided by pi. I'm getting 85. I don't know how many decimals they want. 9.4 if they want 2. That's degrees. I'm in degrees now. I changed 2 degrees. So it's almost a 90-degree angle. Just under a 90-degree angle between those two cities. Is that making sense? Questions I can answer? Like physics. Physics was the hardest thing I did at junior college for sure. Physics was like math with all word problems. So angular speed, they're telling me angular speed is pi over 12. So angular speed is pi over 12. I'm going to be doing some physics this semester because my daughter's taking physics. Like my wife says, that always means I'm taking physics. My daughter comes to the kitchen table and goes, Dad, let's do some homework. That's always how it ends up. So I'm taking physics this semester. So angular speed is pi over 12. So we're going to take that and we're going to convert, and that's, what are the units on that? That is radians per hour. Radians per hour. So we're going to take that thing. Now, that's angular speed. The radius is 6,000, and they want me to convert it to linear velocity, which is miles per hour. That's what they want. So they want velocity in miles per hour. So I'm just, right now what I'm doing, this is how I do physics, is I just kind of write down the units and kind of start thinking about units. That helped me. Units were a big help to me when I took physics, because I'd read these questions, I'd be like, wow, I don't know, that's super confusing. And when I'd look at units, I would start thinking a little bit better. So basically, they're giving me an angle, an angular speed, and they want, on the equator there, and they want me to turn it into a linear speed. If you want a picture of what's happening, it's a planet, so I can't draw. Here, let me go back to the globe. Yeah, let me do that. Basically, yeah, let's use the little globe thing here. We'll use Earth as our planet. So what they're saying is if somebody, let's say what's that, Flash, that TV show with the guy that runs really fast. My kids like that show. I think it's so, they've got really stupid. But anyway, so let's say he's running on the surface of the Earth here. The first season seemed interesting, but after that, it just was the same thing over and over again. Anyway, like so many shows. So as he's running on the surface of the Earth here, he has an angular speed, which means this angle is changing like, 20 degrees per minute or something. That's an angular speed. Get the idea of an angular speed? Like if I do my hands even and I just start opening them, I can open them really slow. I'm doing maybe 3 degrees a second or something, looks like, right? Or I can open them faster. I'm going like 10 degrees a second now. Get the idea with angular speed? How fast an angle is changing. You could do Math Excel speed. I could do 5 problems per hour. You get the idea? Any speed is what you're doing per time. That's what speed is in physics. What you're doing per time. Right? Time on the bottom. That's what a speed means. Right? So we're talking about an angular speed. So the Flash is running at covering a certain amount of angle per time. And we want to change that into how many miles is he actually covering, called linear speed, meaning along this line, I mean it's curved, but it's also a curved line. What is his regular, like how many miles is he covering per hour? See the difference? They're saying he's covering how much angle, like, he might go through 90 degrees in 10 seconds. That'd be obviously crazy fast. 90 degrees in 10 seconds. How many miles is he covering per hour? That's what they want us to convert. That's the idea of the problem. Okay, so how do we go from it? He's covering pi over 12 radians, that's an angle, right? Every hour. Change that to how many miles he's covering per hour. Well, how do we do that? Well, obviously we're talking about the S equals R theta formula, because we're talking about arc length, right? Based on an angle, arc length. So let's do that first. So S equals R theta. So what's my R? Didn't they give me that? Yeah, right here. Oh, yeah, there's radius, 6,000 miles. That's obviously not the Earth. Wasn't the Earth 4,000? Or no, was that? Yeah, that's some other planet. It's a bigger planet. So 6,000 miles. The angle, now what's the angle? Well, we're going to use the angle as the pi over 12, isn't it? That's pi over 12 is how many radians he goes per hour. You tracking with me? That's the rate. So 6,000 times pi over 12. Use your calculator. This is over 1, so this will be 6,000 pi over 12. I believe that goes in there, doesn't it? 500? 500 pi, I think. That's 500 pi. So S is 500 pi. You with me so far? What are this is where units totally saved me in physics. Like you see right here, you'd read these crazy problems, I'd read them too, and I'd go, I don't know, there's too many formulas, there's too many words, I don't know. But you know what helped me was the units. They were like light in a dark path guiding me. So I ask you again, what are the units? If you can remember what the units are, you'll know what to do next. What are the units? 500 pi what? Dogs in the kennel? What is that? 500 pi, it's S. It's S. What is S? S is arc length, right? So it's a length. It's not an angle anymore. It's a length now. It's not an angle anymore, right? S is a length. And what units for length do we have up there? Miles. That's got to be miles. If you remember that, it's so helpful. That's totally saved me in physics. Go, okay, I'd think, okay, that thing's miles. And then I would think, what do they want from me in the end? I'd always see, what do I have, and where do they want me to go in the end? This is exactly what I'll be doing with my daughter this semester in physics. Well, I got miles right now. Where do I go in the end? Miles per hour. Right? Oh, actually, I'm sorry. That is miles per hour. Why? Because what was pi over 12? It wasn't just radians, it was radians per hour. So that is miles per hour. We're done. Oh, and they want round to the nearest whole number. Oh, so they want me to use my calculator. So take 500 times pi in your calculator. 500 times pi. I'm getting 1570.79. Nearest whole number, 1571 miles per hour. That person's going 1,571 miles per hour. 1571 miles an hour.